Good morning, Professor.
Good morning. Hey everybody, so today we're going to be talking about some polynomials. We're going to see what polynomials are before moving to the addition and subtraction of polynomials. And in the next class, we're going to do the multiplication of polynomials. So let's first define them and see how to identify a polynomial. So the short answer is a polynomial is basically an algebraic expression. Just like we did last time, it's an algebraic expression, meaning it's a combination of numbers and letters. It's even a simpler type of algebraic expressions. We're going to see why. So differs from the algebraic expressions. It has a certain restrictions. For example, for example, negative powers or radicals or fractions. We're going to see those in a moment. Let's first write a definition. So polynomial is basically an algebraic expression. Okay, so that's the short definition. Algebraic expression we talked about previously. They are basically, again, numbers and variables together. But a polynomial, so it's an algebraic expression without the following types of terms. So, okay, so without. Polynomial is an algebraic expression, but it does not have the following types of terms. One of them is negative powers. So polynomial does not have a negative power. All the powers are basically whole numbers. It would be 0, 1, 2, 3, and so on. No negative powers, for example, x3, for example, the power -2. So you will not see this in a polynomial. So polynomial does not have negative powers. Also, without variables in the denominator. Without variables in the denominator. So you won't see a term like this, for example, 7 over x. So x cannot be in the denominator, polynomial. So it doesn't have this, it doesn't have this. Also, speaking of powers, it can only be whole numbers, meaning the powers can be 0, 1, 2, 3, 4, and so on. It cannot be decimals, it cannot be fractions, for example, or radicals. So no radicals. Or non-whole number powers. Which means, again, you cannot have, for example, a power like this 1 over 2, or the power cannot be, for example, a decimal. These are not whole numbers. So the powers can only be, for example, 0, 1, 2, and 3, and so on. That's it. No negatives, no fractions. Also, fractions or powers of fractions are basically radicals, as we saw before. So you won't see something like this. So this is basically the same as we saw before. If you haven't seen it yet, I'm going to talk about the radicals in the future. So radical x is the same as x to the power 1/2. So polynomial does not have any of these. No radicals, no fractions as powers or decimals, no negatives, and also no x in the denominator. So if an expression has any of these, it will not be considered a polynomial. It will not be considered a polynomial. It will still be an expression, but not a polynomial. So I'm going to give you a few examples of what is some expressions that could be a polynomial. So 3x is seconds minus 5x plus 1. And then maybe 5x plus 5x to the third plus x to the power negative 1 minus 4. And maybe this also. And another example. Okay, and that's another example. It may or may not be a polynomial. We're going to see which ones are polynomials, which ones are not. And maybe also, let's see. Something like this, 2x and plus 5. And finally, 2x plus 4x minus 2. So all these are expressions, okay? Everything is an expression, meaning numbers and letters with some operations, but some are polynomials, others are not polynomials. So again, polynomials do not have any of these types of terms. If you look at the first one here, this expression, is it a polynomial or not? Everybody, is that a polynomial or not? The first one.
Yes.
Yes.
It is a polynomial, that's right. Simply because it doesn't have
negative power.
That's right, it doesn't have any of these. So that's good. So this is a polynomial according to the definition. What about the second one? Is it a polynomial or not?
No.
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 Okay, that's right. What makes it not a polynomial?
Because
This
it has
minus
the
one.
negative power.
Because of the negative power, right? That's right. This makes it not a polynomial. It's just an expression. Then with to the next one. Is that a
Yes.
polynomial?
No, it's not one because it has the variable of the
Denomination.
But a polynomial should not have this. So is it
So it's
this?
Not a
No.
power.
Do we have a variable in the denominator here? The
Okay.
Yes.
denominator is this. The denominator is this. But it doesn't have a variable. This is a numerator. So here it says you can't have x here, not here. Okay, so this is fine as long as the x is not here in the denominator. So this is a polynomial.
The second one will be an example.
Okay, that's right. This one
Yeah.
here now.
Next one. Yeah. So this one is denominal in the
That's right. That's right. So this is clearly not a polynomial. Why?
Oh, okay, I see it because the denominator is 4.
That's right.
This one
Here,
is X. Oh, got it.
that's right. So here the denominator is, as you can see, we have x in the denominator. So this is not a polynomial.
Yes.
Okay, because x is in the denominator. And then the next one, is it a polynomial?
Oh, yes, it is. Yes.
Yes. So
Not
it's more clear.
poly-
It doesn't have any of this, so that this is a polynomial.
yes. Yeah.
And finally, the last one,
No.
No.
it is not. Okay. What makes it not a polynomial?
Because of the radical. No, not the. Yeah, the radical.
That's
The
right.
x in is not should be
Because
not.
of the radical. That's right. Because of this x. This is fine, but this is what makes it not a polynomial. So not a polynomial.
Why do we need it, this polynomials?
I'm sorry, what was that?
For what? For was it? Well, how it's useful? Polynomials.
Well, just like every topic in math, it's definitely used somewhere in some field. Okay, we're going to see more stuff. We're going to see more applications and examples in the future. Okay, so math, all of it is useful. That's why we do it. So we study it for a reason. One of those is functions. We're going to see functions later, equations, and a bunch of other things. Okay, so this is basically a little definition of polynomials. So it's just an algebraic expression made of some terms. The next part we're going to talk about is the types of polynomials. You're going to see the types of polynomials based on the number of terms. Based on the number of terms, actually, we can name these polynomials. You could have one term like this, or you could have three, in this case 3, maybe 2, and so on. So let's see how that works. Types of polynomials. Let's first talk about terms. So a polynomial is basically a sum of terms. Poly is a sum of terms. Terms are these, like I said here. So it could be 3 terms, it could be 1, it could be 2. The term, let's say, for example, that one or this one here. That's a term, and the term is made of 3 things. So we have the variable. So sometimes it has a variable, sometimes it doesn't. Okay, so this is a constant term. These are constant terms. These are variable terms. So this is a variable. This is the number before the variable. This is 3 times x. 3 times x to the second. So this number, we call it the coefficient. Okay, and of course, this is the power of the term, power or the exponent. So each variable term is made of these 3 things, each variable term. Some terms don't have variables. We call them constant terms. As we said before, previously with algebraic expressions, we have variable terms and constant terms. Constant terms don't change. They don't have a variable. But for those, for example, if you take 1, it is also a term. So 1 is also a term, which we can write like this. So a constant term, the power of the constant term is basically 0 because of the invisible variable. Okay, so a constant term, think of it as it has an x next to it to the power 0, and we saw last time that this is 1. Anything to the power 0 basically is 1. 1 times 1 is 1. So this is basically just 1. So now we can say that the power like this is 0 for constant terms. So all constant terms have power 0, not the power of the number itself, not power 1, or 4 has a power as 1, but we're not talking about that power. We're talking about the power that of the variable. So if it has a variable, the power should be up. If it doesn't have a variable, think of it as some variable to the power 0. That's why, I'm sorry, not to 0. So the power of a constant term, remember that is 0. The variable should match whatever variables are in the other terms. For example, here we have x, which could be an invisible x also. And then, of course, we can talk about the coefficient. So now we can think of this as a coefficient of an invisible variable. So that's the coefficient. And that's 1. Okay, so 2 types of terms, either variable terms, they have 3 of these, or if it's a constant term, the most important thing to remember is the power is 0. So the power is 0 for that term. And again, you can think of it as an invisible variable, and whatever constant here is also the coefficient of that invisible variable. Okay, so now that we know what terms are, let's classify polynomials based on the number of terms. So a polynomial could have 1 term, or it could have many. So it's a sum. It's a sum of terms from 1 to whatever number, however many terms a polynomial might have. The first type, or the first name of polynomial, is called monomials. So monomials, or a monomial, has exactly 1 term. So mono, 1 term. For example, just 2x to the 3rd. So that's a monomial, or maybe just negative, for example, 7. That's also a monomial, 1 term. The power of this term is 3. The power of this term, what is the power of this term?
X in power of 1.
is 0. That's right. It's a constant. So the power of it, not the power of 7 itself, the power of it as a term, as a variable. Again, think of it like this, power 0. So those are monomials. The second topic is binomials. So binomials have two terms, obviously. The word bi for two, binomial, or two terms. As an example, 5x plus 4. That's it. That's a binomial two terms. Or maybe 2x to the fourth minus 7x to the second. It's also binomial with two terms. So again, the power of this term is 4, 2, the coefficient here is 2, the coefficient here is -7, and so on. Could be variable terms, constant terms. And then we have trinomial. How many terms does a trinomial have? Based on
Three.
this?
Three
Trinomial,
terms.
right? That's right. Tri for 3, tri for 3, bi for 2, mono for 1. So 3 terms, for example, this one here is a trinomial. Because it's a polynomial, it's a trinomial. And this one, where is the other one? That's also a trinomial. This one is not a trinomial because it's not even a polynomial. So even though we see 3 terms, but it's not even a polynomial, so we can't call it a trinomial. So 3 terms. And again, any of the 3 terms, let's say 2x to the third minus 5x to the second plus 5 or 6. It's trinomial. Again, all the powers are fine, no negatives, no decimals, or so on. So it is a trinomial. And anything with more than 3, is called a polynomial. So poly basically means many. Okay, a poly, where the prefix poly stands for many or multiple. So if they have 1, 2, 3 terms, we precisely call them these. But if it's more than 3, for example, 4 or 5, basically we call it a poly. So more than 3. Example, any 4 terms, 5x to the third minus 4x to the second, for example. So next, and minus, for example, 8. Okay, 4 terms. So terms are separated with additions and subtractions. So between each 2 terms, it's going to be it's a sum. We said here it's a sum because every subtraction we can think of it as a sum. Every subtraction we can think of it as plus something. Plus something, even this minus here, we can think of it as plus something. So that's why we call it's a sum, not necessarily a subtraction, but a subtraction can be turned into a sum. When you say 5 minus 2, it is technically 5 plus minus 2. So everything is is an addition. That's why we say we call it a sum, but technically it could be a subtraction in between, which is basically an invisible addition. Okay, so that's for terms. As we said, plus 8. So that's 4 terms. And again, it doesn't have any of these here. So those are the names, okay? Just names based on how many terms. And again, each term, remember, it has a coefficient and so on, variable and power. Another thing also, another characteristic to polynomial is its degree. The degree of a polynomial. So it's very simple. The degree of a polynomial is simply is the highest power of all the terms. So as we said here, each term has a power. So when you look at a polynomial, you just look at the highest power of all the terms. Not the highest coefficient, but the highest power of all the terms. For example, what is the, let's say, 7x to 6 minus plus 2. So this is a trinomial here. What is the degree of this polynomial? What is the degree based on the definition? What is it?
Exponent 6.
That's right. So the degree is 6. It's the highest of all the powers. It might not always be arranged in from the highest to the lowest, but it is always the highest degree, not the highest coefficient, the highest degree. What about this monomial here? Let's say, what about this monomial, negative x? That's also a monomial, one term. What is the degree of it?
0,
Oh,
1. The degree is 1, the power 1.
because
It's
yeah.
basically when
1, that's correct.
you see something like this is basically, what about, so this term, the power is 1. What about the coefficient? What's the coefficient of this term? The coefficient.
1,
Not 1, but
Minus 1.
that's right, negative 1. So the coefficient, of course, the variable, and the power. The power here happens to be the degree because that's the only term. But if you have another term with a higher power, that higher power would be the degree. Okay, so that's basically how you classify or how you name polynomials based on the number of terms, based on the powers. Look at this polynomial here, the last one, 4 terms. What is the coefficient of the second term? What is the coefficient of the second term?
Which one?
This polynomial here.
More than 2 times.
What's the coefficient of the second term?
4. Wait.
Negative.
Negative 4.
Negative 4. So we have 4 terms, 1, 2, 3, 4. This is the second one, so the coefficient is this. What's the power of the third term?
1.
1.
That's right. Power is
It's 1.
that's right. And what is the power or the fourth of the fourth term?
1.
0.
0. So this is the fourth term.
X 0.
The power
Yes.
of it is an
X
invisible 0. It's not the power of the coefficient, the power of the variable. The variable would be basically invisible at x to the power 0. So again, a constant term has a power 0. Constant term has a power 0. We don't care about the power of the 8 itself, but about the invisible variable. And here, of course, it's 1. The coefficient here is negative 4, and so on. The coefficient is 5, positive 7. So each term has its own coefficient and the sign. So coefficient here is negative 4. Okay, so a polynomial is made of terms. A term is made of these 3 things, and we name polynomials based on how many terms they have, 1, 2, 3, or more. Okay, so they're basically, again, polynomials are just a specific type of algebraic expressions, specific, simpler type that doesn't have any of these complex stuff here. Simpler because powers are always positive, no x in the denominator, no confusing powers, so they're easy to add, subtract, multiply, and divide. So now let's see how to add. Again, addition of them and subtraction is exactly like we did before with the algebraic expressions. Let's do some more of those examples today. So addition.
Parker, do you simplify them or no?
Simplify them? Yes. Simplify, add everything. So add a subtraction of polynomials. So you can add 2 or 3 or 4 polynomials together into one, just like we did with the algebraic expressions, simply by combining like terms. For example, we can find the sum of 5x to the third minus 6x plus 1, and something else, maybe negative 2x or 3, maybe 2x to the third, okay. Minus maybe 8x plus 5. Okay, so we have two trinomials. So we can find the sum, meaning the addition of the two. We can put the two together into one. Or even more, you can even add not only two, 3 or 4 or 5, whatever, you can put them together into one. It's very simple, just like we did with the algebraic expressions. You want to write them first together. So the first polynomial and then a plus. Of the
And the
addition.
parentheses,
That's right.
parentheses, if two.
That's right. We may or may not need parentheses here. So
If you sure you can just multiply the plus inside. Because,
that's right. So
yeah, combine.
well,
Distribute it.
to avoid that confusion, it's just start simple now. It's just avoid that minus here. So
Okay.
you have an addition. So addition because of sum,
Plus.
an addition. Then I'm just going to put the other 3 terms next to. That's it, just put them together. Again, we don't even need parentheses. We need those mostly for subtraction, as we're going to see later. For addition, just put them together. It doesn't even matter which one we write first. The commutative property we talked about before, 2 plus 3, 2 plus 5 is the same as 5 plus 2. So it doesn't matter which one goes first. But with subtraction, it does. With subtraction, it does matter which one goes first. So
There's a different answer.
that's right. So these are not the same. For addition, doesn't matter, but with subtraction, as we're going to see, the order in which the polynomials go matters. For addition, doesn't matter. We don't even need parentheses. But here with subtraction, we're going to need parentheses, as we're going to see later. So now that you put the two polynomials together, the rest is simple. Yeah, we're just going to need, just going to combine basically like terms. So what do we combine here to simplify this?
We're gonna combine the x exponent 3. It's gonna be 7x power 3.
That's right. So we're going to combine these two together because they are like terms, which means they both have same variable and also the same power. So that's 7x to the third. Also, what else do we combine?
And it's gonna combine 6x minus 6x and minus 8x.
That's right. I'm going to combine those. And
you're gonna
also,
combine 1 plus 5.
That's right. Also the constants together. So this would be 5x to the third. And we're going to move this next to it. We're going to move this next to it, just like we did with the algebraic expression. So the term here has a plus coefficient that's positive. So we're going to move the whole thing next to this. So it's going to be plus 2x to the third. Then we're going to move these back, negative 6x with the sign. So the term will move with the sign. So it's going to move back here, becomes negative 6 next to the similar term. Because they both have the same variable and the same power. So the power again here is invisible 1. Then we have the constants together. So we're going to combine the constant here, plus 1, with the other constant, plus 5. So we're going to move the 1 with the sign. So we get plus 1, positive 5. This step is normally optional. You can just combine right away and write the answer. But this is the proper way to do it. So make sure you move the term to the similar term and make sure you bring with the sign with it, the sign of the coefficient. So this will be 7x to the third, negative 6 minus 8, that's negative 14x. And finally, plus 1 plus 5, that's positive 6. So this is the sum of these two polynomials. Both trinomials, we end up with a trinomial. It doesn't necessarily have a trinomial. Sometimes maybe 2 or 3 terms may cancel out. You could end up with 1 term. But when adding them, we basically just combine like terms, very similar to algebraic expressions as we did before. So it should be pretty simple. We just combine basically the coefficients And the like terms, again, the like terms must have the same variables and same powers. As we saw before with expressions, so like terms have the same variables and powers. And if they don't have the same power, they don't have the same variables, we can't add them. For example, these two here, the powers are different. We cannot add these. We can't say 5 plus 7 because 6 and 2 are different powers. Even though the variable is the same, the power is not the same. So these are not like terms. They don't add up. So that stays like this. So always make sure you have like terms, which means, again, same variable and power. Okay, it should be pretty simple to add polynomials. There's no big deal. Just adding some terms, some like terms. Any questions so far, everybody? Everyone?
No.
Any questions? Everybody else? Everybody else in the class? Any questions so far?
No.
Where is everybody else? I only hear from 1 or 2 people.
No question.
19 people in this class, but
No question.
No question, no question.
all right, everybody, please feel free to engage, ask questions, answer questions any moment.
Everything's clear.
So yeah, so this is again pretty simple, just like the expressions we saw before. So I may say sum, I may say add, and then you have some polynomial, let's say 2x to the 4th plus maybe to the 3rd minus 5x. And this maybe you add to another one. Let's say the 5x to the 2nd minus 3x. So there's another example here. So basically we add in 2 polynomials here, 2 binomials. So the sum, or may say add, so again, pretty simple, just write the 2 polynomials plus, and the other polynomial minus 3x.
Add
And-
and sum, it's the same.
I'm sorry, say it again?
Add and sum, it's the same.
That's right. Sum, yeah, sum is a result of addition. So we put both polynomials
For
together.
example, you sum the sum of expression. This example, add. It's the
Yes.
same.
Sum and addition are the same thing. Sum is the result of adding 2 things or more. Okay, so now we have another one here. Let's
You're gonna
put,
combine the like term? No, you're gonna,
Okay.
because that, we're gonna do 2x exponent 3
Mhm.
plus 5 exponent 2 minus 5x minus 3.
do we have any like term? Any like term to this one?
No.
That's right.
No,
There is no
that
like
one.
term. That's right. So x3, there is no x3. So write it down first. Then it's gone. Then what about this one? Does it have a like term?
Yes, minus 3.
That's right. So we're going to bring this over negative 5x. Write it next to the negative 3x. Those will be combined. They have the same variable, the same power. So cross those out. Finally, this one left by itself, 5x to the 2nd. It doesn't have a like term. So now,
2x.
that's right. So this here stays the same. It doesn't have a like term. You can bring the other one next to it. So power 3 followed by power 2. No like term, but I'm just going to write it next to it. Finally, we're going to follow this by
Minus 8x.
not positive.
Got it.
So we're going to combine them, not multiply, just combining the coefficients. Combine negative 5 and negative 3. That would be
8.
Plus 8.
what is it?
8. 8x.
Negative 8x. That's right. So these are like terms. So basically we add in and subtract. This is addition. This is addition again of polynomials, so we're doing -5 minus 3, which is -8. So we're combining basically the coefficients, not the powers, just the coefficient. The powers stay the same, have to be the same first to combine two terms, and then they stay the same. And okay, so addition is pretty simple, pretty straightforward. Again, make sure the powers are the same before you combine two terms. Subtraction also is pretty simple, but it has, again, the order matters, as we did here earlier. The order matters. So when you add two polynomials, the order doesn't matter. But when we subtract two things or two polynomials, make sure the order is right, because you can't just put whichever one you want first, it will not be the same. So we have to be careful with the wording of the question. Usually the wording of the question tells you what to subtract from what, which one goes first, in other words. So we have to figure out the right order before we can do this. So one way to ask, or one way to put a question of subtraction is, here we said the sum of, we may say the difference. For the subtraction, we say the difference. Difference, or any other word for subtract from, or minus, or whatever. There are many words to say to mean the difference, to mean the subtraction. So one of those is the difference. So the difference of, let's say, some polynomial. Okay, and from this, so the difference of and some other polynomial, let's say maybe 4x to the second and plus 3x minus maybe 2. Okay, so again, remember, sum, that's addition, difference is subtraction. So difference of this and this. When it says difference of this and this, we keep the same order, this minus this. Just like when you say the difference of 5 and 2. The difference of 5 and 2 is 5 minus 2, which is 3. The difference of this and this means this. We're going to write that polynomial first. And since we're subtracting, so we're going to have a minus. And not only that, it is important, we have to put the other one in parentheses. For addition, again, no need for parentheses, because when we basically, if you have parentheses here, if we distribute the plus in the over the parentheses, nothing changes. So parentheses here are unnecessary. But for subtraction, you have to put the second polynomial, whichever goes second. For example, this one here goes second. It has to be in parentheses. Parentheses is right after the minus sign. That's important. So we keep the same order, this minus this, and we put this together.
Yes,
okay, so that's the first step. That's the setup. It's a subtraction. Now we can go ahead and simplify this, put this, put this together, whatever, just like we do with the algebraic expression. So what is the first thing we do here to simplify this, or to perform this subtraction? What do we do first?
It's over the parentheses.
Okay. Okay, so we need to
Distribute the -1. -1.
exactly. So we're going to distribute this over the parentheses. So think of this negative as a -1, that's right. And we're going to multiply it. We're going to multiply that by all of these. So this minus affects every one of these terms. Every sign here will change basically. So negative times positive will be negative. Then you have -1 again times positive, it's -3x. What else?
Positive 2.
Exactly. So -1 times -2, that's positive 2. So once you clear the parentheses, then basically we're back to something like addition. Now we just have a bunch of terms together. We just need to combine them, move the things around, and simplify. So distribute first, then combine. So when you distribute, again, we multiply. When we combine, we add and subtract, just like we did again with the algebraic expressions before. So these are polynomials, are just another name for expressions. So whatever we did before, basically, we're doing the same thing now. There is a 2 here. Now that we have a bunch of terms, this is like simplifying. This is like simplifying the algebraic expressions we saw last time. So we're going to combine any like terms. So do we have a like term to this one?
Yes.
Yeah.
Yes.
Negative 4x.
That's right.
It's gonna be 2x.
That's right. So we're going to combine those. So it's going to be, so it's
2x
6
squared.
minus 4. So it's 6 minus 4. So basically a positive 6 and the minus 4 would be
2x
2x
squared.
plus 2 is gonna be like
That's right. Then we move on to the second term. Do we have a like term?
minus
Negative x.
8x.
Negative.
Negative 8x.
That's right. So negative 5 combined with negative 3. So again, like we said here, negative 5,
And
negative
plus
3 make
3.
negative 8. Negative 8x.
Plus
And
And
what
positive
else?
3.
Exactly. So we plus 1 here.
You get
Plus
positive
3.
3.
That's right. So that's combine the constants together. They're both positive. We just add them.
Professor, I have a question.
Mhm.
A lot of the stuff I'm doing, a lot of mental math. But do I have to write it out like the way how you're writing it out right now?
Well, we didn't. We skipped one step, right? So this is probably the minimal number of steps we can do here. We didn't do that step when we put them together, but yeah, so at least a couple of steps. So I didn't write them first next to each other like we did here earlier when we moved to, what was it? Not here. So here we put them together first and then we subtract, but I believe we skipped a step or two, but that's fine. If you, show at least the main steps, okay? And not every detail like I do here. I try to show every single step so everybody sees exactly what's going on, but
Yeah, I get that. I was just asking because for the homeworks, I was just asking if I had to write everything out, basically.
yes, the more you write, the better, okay? So
Okay.
you can't just be the final answer, that's for sure. You can't just write the final answer. Also, you can still just write a few steps, maybe not all the details, but I would say enough so people can follow the work and see how you got the answer.
I got it.
All right, so that's what happens when it says the difference. So whenever you hear the difference of something and something, for example, what is the difference of 8 and 4 or 8 and 5? What is the difference of 8 and 5? Everybody? So simple.
What's the coefficient?
What's the difference of 8 and 5?
8
8
plus 5.
5.
What is it?
8 minus 5, 4.
Difference of 8 and 5. What is it?
4.
Eight.
I'm sorry, 3.
That's the difference?
Yes,
3.
3.
3.
So difference means subtract in the same order.
Subtracting. Oh.
So difference of 8 and 5 is 8 minus 5, which is 3.
3.
What's happening is whenever you see difference of two things, so you do the first thing minus the second thing. If another word is used for difference, it may change the order. Okay, it may change the order. This may have to go first, depending on what word is used. For difference, keep the same order. If it says something like subtract, let's say plus 3 from maybe 9x minus 2. So before you answer this, what's if we said subtract 2 from 8? What is subtract 2 from 8 equal to?
No, it's subtraction. We do not subtract
What is the answer?
equation from the second equation.
Okay, so what is two
It's negative.
what's 2 subtracted from 8? When you say subtract, okay, subtract.
It's plus.
Okay, what is the answer? Subtract 2 from 8. What is it?
6.
It is
It's
6.
minus.
How do you get 6?
2 from 8 is negative 6.
No, it is 6. How do we get 6?
You say subtract 2 from 8, like that 8 is bigger than 2.
No, it doesn't. Subtraction is not about what's bigger than what. It's
Oh
between-
no, I said.
Mhm.
Oh,
What is,
now I said.
everybody, what is
it's like
2
from.
subtract from
I
8?
said from 8, from 8. Like it's 8 minus 2 equals 6. I understand now.
So it's 8 minus, when you say subtract from 8. So you have to put the 8 first. And
First and the second.
from
Got it.
that, we do 6. So if you see subtract from, this has to go first. Then this. But if we
And
see
this
difference,
second.
we keep the same order.
Got it.
Everybody, do you understand the difference here between this and this? Everyone, it's important. The wording, the order changes based on the wording used. Okay, so now let's apply this to polynomial. So which polynomial do we write first here when we do this subtraction? Which polynomial goes first?
Gonna be 9x negative 2
All right.
negative parentheses of negative 5x plus 3.
Okay, so subtract. So we're going to put a minus and parentheses. So we have to put parentheses. So subtract this from this. So again, this has to go first. Unlike here, when you said the difference of this and this, we keep the same order, this minus this. But if we say subtract from, the from goes first. And from here, we subtract this one. So we have negative 5x plus 3 in parentheses. And the rest again should be simple, just like here.
You distribute the negative inside the parentheses.
So I need to distribute, that's right, so 9x minus 2. So this would be plus 5x. And also negative times positive, which is negative.
Negative 3.
This of course would be, combine these, combine those. So this would be 14x.
It'll be like 14 minus 5. 14x minus 5.
Right? And negative or minus 5. So that's basically, these are the main ones, the main words we use for subtracting these polynomials. You may see some other word, but again, be careful with the wording, and that tells you the order. For addition, again, the order doesn't matter which one you put first. You don't even need parentheses, you just need to put them together. But with subtraction, again, the order matters. So we have to put the right order in order to get the right answer. And that's pretty much, again, it's very simple to add and subtract polynomials. Again, remember there's details here, there's technical details and how to tell whether two polynomials are the same or not. I mean, are like terms, and be able to tell the degree and whether an expression is a polynomial or not. And the names. And in the future, we're going to see how, next class, we're going to see multiplication. And sometime later this semester, we're going to see the division. The division is a little complex. It involves something called factoring. So we'll see it later this semester, but we'll do the multiplication next time. Any questions, everybody, about any of this, especially these last two problems? Do you guys understand the difference here?
No.
We're all clear on that.
Okay, everybody, so if you have any questions, please let me know at any moment.
For the homework, there's a due date that says it's due on the 30th. That's correct, right? For like Pearson?
Right. That's correct. If you have any homework related questions after the class ends, I can stay with you for some time. If anybody has any questions about the homework or Blackboard or the ebook, I'll stay and make sure I address any questions you may have, because I know there's some confusions there with the homework and the links and everything. So please stay after class if you have any questions. I'll be doing a little Q&A or a little tutoring if you guys have any questions. Okay, so for now, any questions about this before we move on to maybe some practice or something?
No.
Any questions, everybody? Okay. All right, so let me give you a little practice here. Okay, something like this to do on your own. Okay, so first one, basically give you a couple of polynomials. Determine which of these are polynomials. Polynomials, and then name or give the degree, or give the power, as we saw before, power, variable, and coefficient. Power, variable, and coefficient of each term, of each polynomial term.
So if it's not a polynomial, we don't have to.
Exactly, that's right, of each polynomial term, not just expression. Polynomial term, and give the degree also. Give the degree of the polynomial.
Professor, give the what?
The power, variable, and coefficient. Okay, so I'll give you a few, and if it's a polynomial, give these things. If it's not a polynomial, just skip it. Only for each poly term. Okay, means if it's a polynomial, then find the terms and so on. If not, just move on to the next one. So 5x to the second minus 7x to the power -1 plus 3, and 2x to the fifth plus 4x to the third minus 1, and also 5x plus maybe okay, it's another one, and of course that's that. So it should be 2 and 7x plus 3 over x. Again, only if it's a polynomial, give this, and give that. If it's not a polynomial, you move on to the next. And some additions and subtractions. Give the power, give the degree of the polynomial, and also its name. Okay, and its name here. Okay, so give the degree and name if it's a polynomial, and also power, variable, and coefficient. And find the sum of some polynomials here. So 7x to maybe the third. And also 2x to second. Okay, here we find the sum. Subtract. Subtract maybe 2x, the third minus 5 from and finally going to find the difference of a couple of polynomials. X to the second minus x plus 3 and maybe 5x to the second plus 3x minus 1. Okay, again, this should be pretty simple. This is something you need to understand, not something you can memorize. So if you understand the details, all these can be very simple. You can do them quickly. And addition and subtraction also are pretty simple, just like.
Yes, sir. I got a simple question.
Mhm.
In order to be a polynomial, it should not have the negative power,
Should not have any of
this
these.
variable, or anywhere.
The variable, negative power on the variable. So none of these here.
Okay,
Negative power.
so within a free term, the negative power, it's all right.
I see what you mean. I forgot an x here. That's what
Oh,
you're
yeah.
talking about, right?
Now it changed.
Okay. That's right. So you shouldn't have any negative powers. Okay, everybody. So that's your practice here. I'll take a few moments to do this. Okay, give you about 10 minutes or so. Still have some time. Okay, you may take a short break if you want to. Short break before you do the practice. And when we come back, we'll go over this together. Okay, so I'll see you in a few minutes. All right, how's everybody doing?
Good.
I'm done. Okay, let's see.
Okay, okay. Everybody else?
Okay, 191.
Done.
Mm-hmm.
Everybody else, you done?
Yeah, I'm done.
Okay.
Sorry, Professor. My computer went to sleep. I don't know what it happened. And I got kicked out of Zoom.
All right. All right, so let's go over these problems together, everybody. All right, so first, let's determine which ones are polynomials before we start doing the powers and degree. Is this one is a polynomial?
No,
No, so that's a no. We don't need to do anything else. That's it. This one?
yes,
Yes.
it is.
Yes. So we're going to find the degree and everything for each one of these terms. What about this one?
Yes.
Yes.
Yes, this is fine. And this?
No.
No.
That's right. No, because of the x in the denominator. So forget about those two. We're only going to work with these. So so 2x 5 plus 4x minus 1. So let's first, it says give the power.
It's -1, Professor, not 3.
That's right, -1. First it says, so we're going to give the power variable and coefficient of each term. So what is the coefficient here? Power variable.
2.
Wait.
Okay.
X.
Variable x.
X.
Uh,
5.
5.
So the power is 5, right? Power is 5. Coefficient is
5.
So
No, the power is 5. The coefficient, the variable is X. The coefficient is 2.
coefficient is 2.
that's right.
How can I
Coefficient
do?
for this one. Again,
Power
power.
is 3. Variable X and the coefficient is 4.
That's right. Power is 3.
3x.
Variable x.
And
And
the
coefficient
3 is 5.
that's right. For this one, we have -1.
Who is this for?
We have -1. So
No, throw that out.
think of it like this. So what's the power of the variable and the coefficient?
The power is 1.
0.
Is 0.
Variable.
Variable is
Do you know
X.
your phone number?
Coefficient minus 1.
And
And
One.
1. -1.
-1. -1. Let's go over to the other one. So we have
646.
please mute your mic if you're talking to yourself or someone else. 2x over 3. Same thing here. So that's a polynomial. So the first term, what is the power variable coefficient for this one? Power, obviously 2. What else? Variable is also x. And
5.
coefficient is 5. That's right. The last term here. What is the power?
X.
The power.
The power is 2.
1.
The
The
power
power is 1.
No, the power is 1.
is 1. The variable.
Variable is X and the coefficient is 2
The
over
variable
3.
is X and the coefficient is 2 over 3.
That's right. What's the degree of this polynomial? The degree, d.
5.
That's right. The degree is 5. Name. Name of this polynomial.
Trinomial.
That's right. Trinomial. And this one here, the degree is
2.
to the highest power.
Binomial.
Name is binomial. Okay, so polynomials are pretty simple. Name and to name and to classify. Okay, so that's the first part. Now let's do these two. So we have an addition here. So find the sum Sum is pretty simple. You can add your terms right away. Do we have a like term to this one? Do we have a like term? So this is 1, 2, 3, 4. This is 1, 2. Is there a like term to sub next to the third? No. So we're going to write it down. And do we have a like term to this one?
Yeah,
Yes.
those three.
That's right. So it combines with
-2. Yeah, it's
So
gonna be a 3 plus 3
plus 3x. That's right. And then
It's
plus 2
polynomials, see that.
positive 3 minus 1 is
plus 2.
plus 2. That's it. That's the sum. Again, you can combine it right away. No parentheses needed. Just make sure you combine like terms. And there's this other term. Okay. There's another term here. It doesn't have a like term, so it should stay there. This one here. So these don't have like terms. You may move this one next to it. Power 2. You may move it right after power 3. It's still okay, but there's nothing else we can combine.
Mhm.
Subtraction. So be careful again. Which one goes first?
-5. That one. -8 should go first.
So you're gonna subtract like this is -8x 3
So it should go first. Minus.
plus 3. Yeah,
Okay.
and you're gonna distribute
2x. 2x minus
That's
5.
right. 2x. So the third
Three.
minus 5.
third, yeah.
All right. What do we do after that?
-5.
So you're gonna distribute it.
So minus x.
It's on 3 plus 3x
That's
minus 2x3
That's right.
plus 5.
Plus 5. So we
It's gonna
distribute
be-
minus 5.
It's gonna be -10x exponent 3
Right. We're going to combine those two. Okay.
plus 8x. Now plus 3
Right. Plus
Plus
3x
3 plus 5.
plus 5. So this doesn't have x. So these are different. Just bring them over. Bring over both of them because they're not like terms. They don't have the same variable in power. Okay, let's subtract. Finally, find the difference of this and this. So again, which one goes first? Which one of these goes first?
X
Everyone?
squared. The
Which
x1. The x1. X squared.
The x squared minus x plus 3. So again, when it says difference, which is minus, you keep the same order. So this stays there. Minus.
Minus.
Make sure you put the other one in. Okay, so that's basically the setup. Then again,
Yeah.
once we set it up, we distribute first before combining like terms. So the first one stays the same. Distribute, so it's going to be -5x. So the second minus 3x plus 1. So what do we combine here?
Combine the like terms.
-4x. -4x squared.
That's right. So we have 1x to the second minus 5x, that's -4x to the second. What else?
Gonna be
What
2
else we
2x.
combine? Everybody, what do we combine after that?
-x and
the la-
-3x.
The
Gonna
x
be
That would be
-3 plus -3. It's gonna be like -4.
okay.
-4x.
That's right. Be -4 because we have a negative here, -1 with a -3. That's -4x.
It's gonna and plus 4.
And 4.
That's right. Plus 4. And that's basically how simple it is to work with polynomials. Again, it's just a fancy name for expressions. They're basically just expressions. We give them a different name, but the operations, all the stuff stay the same. Nothing really changes.
Professor, can I ask a question? The number 3, subtract. So if we have one of if one of them with minus, like let's say minus 8, we have to put it first.
Oh.
Say it again. I'm sorry, I couldn't get it. Go ahead.
Number 3.
Mhm.
It says that we have to subtract it. Why you put the second expression before?
Yes. So whenever you say subtract something from something, the from has to go first.
Okay.
As I was explaining here. So the
Mhm.
from, whatever the from is, should go first. Just like when you say subtract 2 from 9. When you say subtract 2 from 9, it means 9 minus 2.
Mhm. Okay, got it. Thank you.
Okay. Any other questions, everybody, about this practice?
Mm-mm.
Everybody else, please let me know. And again, after class, I'm going to take the attendance first. If you have any questions about